Hello everybody, Caleb here. This is the first tutorial of COE 318, just re-recorded so that I can recap what we just did on the night of September 19th. So here we go. So what we covered is a bit of an intro kind of thing where I talked about some programming terms that people should know. And I also covered briefly on some professionalism and ethics and the software development lifecycle. Then I dived straight into the OOP, objects-oriented paradigm, and the intro to Java and NetBeans in the form of a live demo. So let's start with the intro. So some terms to know actually include a programming language, which hang on, which is a high level language that tells a computer to do something. And examples of programming languages include C and C++, C is covered in CPS 125. So hopefully you still remembered what you were taught there. Some other ones include Python. A lot of my friends use Python for many different things. I particularly use it for my algorithms and data structures type of questions, just for practice. C Sharp. This is also used especially for people who develop stuff on Windows, or maybe for some people that actually make games, like in Unity. JavaScript and TypeScript, these are used a lot for developing applications on the web, and they are also programming languages. And finally, there's Java, which is this course. There are actually people who develop stuff with Java, like, I don't know, Minecraft. Um, and this course will cover Java, and that's about it. So another thing you may want to know is something called compile. So to compile means to translate a programming language into machine code, and computer only knows machine code. So unless you know a bit about assembly, I doubt anyone will ever know stuff about assembly, unless you work with a lot of hardware and stuff, and need to work with an EEPROM. Then yeah, I doubt everyone would like to learn how to write low-level code like that, because it can be really dangerous to the computer as well, maybe due to human error or something. All right. Uh, Two more terms to know are programming and software development or engineering. Um, the thing is, these two are used interchangeably, and programming in particular involves coding in really small scale projects. Maybe like a small game or a small app for yourself. And it usually doesn't impact lots of people, and the costs are not as high. And of course, the life is maybe a bit short. Maybe it's only for school or something. Who knows? However, on the other hand, software development or software engineering generally means you are coding in large scale projects where teams make decisions together. So your product may have a larger impact, and it is costly, and it usually consists of a family of products for you to work with. And of course, you have many stakeholders or shareholders or many customers you need to work with. So your requirements are broad. Another thing I covered would be professionalism and ethics. So one of the things that I mentioned would be like how the impacts of technology relates to this sort of thing. So nowadays our lives depend on technology. Well, it's obvious because we have computers to view all this stuff. And another thing I need to tell you is software systems maybe those from social platforms like Twitter, Facebook, Instagram, maybe even YouTube or something, can even influence the choices we make. That is how powerful technology is. And another thing that is impactful to us would be failures caused by software or any technology in general. For example, we have the Care Fusion running into really huge trouble because their infusion pump fails to administer medicine at the right time. And we also have a rather recent one, but that's 2 years ago, which involves British Airways actually getting delayed due to technical glitches. And trust me, the passengers are not happy with their delays for up to like one whole day. Trust me, it's bad. So in your spare time, try to think of more examples of software failures we witnessed in our lives. One that I know is actually just Bitbolite being overloaded because scalability is not easy to tackle. Ethics. Well, it basically means how to be a good person while being a software developer at the same time. So one thing you have to know is that the things we develop, even software, can also have ethical implications. So ethical issues include maybe the digital divide that is considering how we're going to make our software accessible to the poor, the people in rural places, the elderly, which are people who are old, or people who are handicapped, or I would say people with disabilities that may need more help using the software. And there's also privacy and safety. Nowadays we care about our own safety and privacy of our own information. So how does our software system gonna handle sensitive information? And how do we make sure that unwanted access is prevented? Another thing would be human rights and copyright infringement. So plagiarism, piracy, permission to use libraries and designs, those are the things we also have to consider as well. And there are many others. Just search online if you want to know more. The gist of the ethics part of the tutorial is that just choose ethically, make the right decisions in every step of software development, and own the programs you make. And along with the responsibilities that come with it. So don't just make a program and don't care about how people think about their privacy, for example. Make sure you consider that every step, in every step that requires sensitive information. Like, how can we prevent the use of this stuff as much as possible? So own the responsibilities that come with the things you make. All right. So after the whole like ethics and professionalism, which I would like to tell you that it is actually kind of covered in CN 100. So make sure you touch up on that. After we covered this stuff, we're gonna dive into SDLC, which is Software Development Lifecycle. So what is in a software development lifecycle? Well, think about this. In CN 100, we learned about effective problem solving. We have to understand the problem, make a plan, carry out the plan, and we look back on it. Okay? This is CN 100 knowledge, so I suppose you know the stuff. And you have applied it before. How about what we do in software development? Well, first we gather the requirements that of a software we need to deal with or make. We design the software based on these requirements. Then we start to implement or code it. We test it, deploy it, and finally we maintain it through maintenance. So how this relates to CN100 is that the steps to effective problem solving exist in the processes in the life cycle. So we understand the problem by gathering requirements. We make a plan by designing how we're gonna approach this problem. Then we execute the plan by implementing, testing, and deploying our programs or apps. And finally, we look back on the plan by maintaining it and providing updates to maybe fix bugs and all that stuff. Now, one of the models of software development's lifecycle that is covered is the waterfall model, which means you take all your time you need to gather your requirements, then you go down and take your time to deal with the design, then you go down to implementation, and then you test it, and then you maintain it. But every step of the way, you have to take time, and sometimes it takes a long time, especially if you have a very large product. So testing generally takes maybe years to get to, and who knows what happens. We may have missed some errors that we could have caught if we can look back in every step of the way. So the thing is, while the waterfall model has a very clear structure, and you have a very clear end goal, and you can like transfer where we are into to maybe people who are new to this thing, like new hires. It has its own problems. Like, it does not handle change as well, so it's really, really rigid. And it takes a long time for people to actually test out. I'm talking about the customers, by the way. And finally, it leaves just too much room for unnoticed errors. So who knows what happens if we forgot about a bug. Are we gonna fix it, or are we just gonna leave it and say it's not a bug, it's a feature? That is one of the worst excuses I have ever heard. Seriously, see a bug? Go fix it. Simple. So here's the Scrum model, which is the Agile model. And basically, it's like asking the question: what if we take all these processes in software development and put them in a loop? Well, first you gather requirements, then you design, you develop, you test, and then you deploy, and then you review the program and look back into like what we did and see if we can add more. Then we do another sprint. So that is what essentially the Scrum model is. We just put the life cycle in a loop, and we just keep on doing it until we are really satisfied or the project is kind of dead. So here are some good things about the Scrum model. Is that it's very flexible to changes. That's the goal of the model itself, because it's, agile. Agile is a philosophy. You can look up what that is. It provides better communication between developers and clients. So now the clients can get involved with the project. So that's what they really want to do, because they are the ones that know best regarding the requirements. It also takes less time to release to other customers. And we can release new features in the form of incremental updates. And that's fine, because, the customers want to get their hands on the products as soon as possible. That's just us being us. However, the thing is, in regards to the cons of the model, it's not as predictable as the waterfall model. So the structure may not be as clear, and the end goal may not be as clear. You may actually end up like leaving behind documentation, or you may have sidetracked it. So as long as you actually update your documentation as often as possible, maybe this will be mitigated. And also, just like maybe other models, it may fail if the deadlines and expectations set to you by your managers are unrealistic, or maybe even set to you by customers too. So if that does not work, if like the deadlines and expectations will not ever work for us, well, expect to get ready to quit and just go to another company that knows how to manage expectations. So here are some other agile models that you can take a look. RUP, XP, Kanban, DSDM, and FDD. I used Kanban in my previous internship, and It's really useful. You should check it out as well. Now, I covered the SDLC and its related topics. Now, let's dive into OOP and Intro to Java and NetBeans. So, the first thing I covered is procedural versus object-oriented programming, which means we have the procedural-oriented programming using some global data and passing them into functions. And the functions may even work with their own local data, and they can also call one another. So I think what I should have done is I think I can like also do this. Like we can also call other functions as well. Like from function 1 calling function 2 to function 3 calling function 1. Something like that. Now, that is hang on. So that is procedural programming, which is organizing a program into functions that operate on the data we pass. How about object-oriented programming? As you can see, we just organize our programs into different containers we call objects. And each object has their own set of data they work with, and they also have their own sets of functions they work with as well. And each object can communicate with another. And that's how we achieve functionality, just like how we do the same thing by splitting the program into functions and calling them. So that is object-oriented programming, which is to organize the program into objects, but they still operate on the data we pass. So as long as we give them inputs, they should be able to do something with it, assuming that it works. Now, here's a procedural programming example. Before we dive into like object-oriented programming, so that I can show you the difference. So in our case, we have the factorial function in the C programming language, and we also have a main function as well. So the factorial and main functions splits up what we basically want in our program. So we have the factorial calculating the nth factorial, and we have the main, which prints out the 65th factorial. Yes, it works because I'm using the long type, which is a large data type. So in our case, what this essentially does is just it prints out the 65th factorial, which I'm not gonna tell you what the huge number is because it's huge. So that is procedural programming. We just split the program into different functions and we run them. Now, let's dive into some OOP. So what's our objects? Well, we have we want to maybe know something and we want to know some information and store maybe some information or even change it. So an object can be anything that we want to know and store information of. And objects can consist of properties, which are attributes that describe it. So how are you gonna describe your object? Do you use its color, its temperature, its name, its length, width, its ID? You can use anything. How about its behavior? Like, what can it do? And we implement its behavior in the form of methods or functions, as we know. So for example, we can move it, we can make noise, we can have it toggle a switch, we can kick it, add or remove it, we can add or remove something to it, or we can eat it. I have no idea what you want to eat, but if it's food, go right ahead. So that is objects for you, which is just a container of properties and behaviors in the form of methods. Now, another thing we say a lot is classes. So a class is pretty much a blueprint or template of an object. So if you're gonna make an object, you may have to create a class that defines what the object can store and what the object can do. So that's classes. And you can create an object with a specific set of attributes using classes. So here's what it looks like. We have the name tag class and main class to run the program. So first, let's head to the name tag class. So we have the name of the class name tag, and then we have the property called name to store the name on our name tag. We can make a new name tag using a constructor. You can recognize a constructor by checking if there is a return type and if the name of your method is the same as the class's name. In our case, yes, this is the name tag's constructor because there is no return type, and we are using the same name as the class name tag. Okay. And what this does is when we initialize the object, we're gonna require a new name. This will set the name property to the new name. Now we can also make methods like getters and setters here. The getter methods will return the value of a property, like in our case the name. The setter methods will change a property, like I want to change the name on the name tag, so I assign the name property, which is only available in this class, to the new name. And then I can also do other things with the name tag, like I can shout out its name. Sure, why not? I can say my name is the name, whatever is the name currently. Now notice that we have something called private and public. So private means that no other class can see it. So only the name tag class can use this. And public means other classes can use it, other classes can see it, and well, other classes can maybe change it. Well, in our case, for methods, we cannot change methods because they're not properties. So how about the main class? Let's take a look. The main class only has one method, which is the main method. The main method is what runs the Java code. And what I did here basically is I made a new object and stored it in the me variable, which is of the type name tag. Well, where did the name tag come from? The class name up here. So we have the name tag, and I'm going to set that to, well, a new name tag that we're going to create using its constructor and the new keyword. Make sure you add a new keyword so that your constructor will know that you want a new object. So that is the syntax for making new objects. We can also do stuff with it with the name tag now. So using the me variable, we can access different functions like say name, set name. We can like just set the name to something like Johnny. We can also say the name again. You can do it how many times you want, like however many times you want. Okay, so that is the example class of in Java. So we're gonna do more of this in a bit. So what I also covered, which is to like quiz. This is to quiz you a bit on your CPS 125 knowledge and see if you can like interpret Java code using the pre-existing knowledge you have. For example, here in each line of code, first I have I declare an integer variable named size and give it the value of 27. Then I declare a string and give it the value Fido. Then I make a new dog variable and dog, assuming the class exists, will make a new dog for me. Okay. Then, assuming that x exists somewhere in the class or something, I'm going to set x equals to size minus 5. So we're subtracting the size by 5. So the value would be 27. If I can find my cursor, 27 minus 5, which is equal to 22. So you're essentially storing 22 into x. Okay, sounds good. Next, hang on. Next, we have a while loop here. As long as x is bigger than 3, we're gonna tell the dog to play. Well, whatever that means to a dog, though. And we're gonna end the loop here. The thing about this while loop is that there's no statements updating x, so that's gonna be an infinite loop if x is bigger than 3, because we are not modifying x at any point in the loop. So yeah, pay attention to like what you're writing inside the while loop, because who knows what will happen if you ended up with an infinite loop, right? All right. Another thing that we learned in CPS 125 is arrays. So here we declare an integer list and we put 2468 in it. So that's about it. Yeah, nothing special here, and it's CPS 125 knowledge, so I assume that you actually know this stuff. And then system.out.print basically is the Java equivalent of C's printf, or I think it's print. I'm not sure. I think most likely it's just printf without the formatting. So what we have here is we print out hello in a command line, and then we print out dog and the name of our dog currently with at the command line. In our case, the name is Fido, so we're concatenating dog with Fido. So we end up with dog Fido. Another thing in this this section is we have the string variable called num, and we set it equal to quote unquote 8. Why did I say quote unquote? Because the string 8 is not the same thing as the number 8. Please don't mess it up. What we did in the next line is or what this next line is doing is actually just converting the string 8 into the actual value 8. So essentially what we have is we have the number 8 in Z, as long as it works. Now, the next section is a little bit daunting because it's something pretty new to many, and it's called the try and catch statement. I think we were going to cover that in the future, but just to give you a small gist, it just means it's like saying I would try to do something, but I'm not sure if I can do it correctly. So here, I will try to read a file, but what if I cannot find the file? Well, I will print a small error message, just in case. And you can try many different things other than a single line of read the file. So that's it for the Java example. So here are the answers. Now, let's go ahead and let's dive into a live demo, which is to make a class. I've already done this stuff, but I'm gonna do it again, because why not? So what I would do is I will make a simple class called rectangle, and I will give it a width and a height. And I will also use getArea to calculate the area without using any properties. So I will also make a class to test out the rectangle class with a separate file. And I will make 2 rectangles, give it any dimensions, print out the properties of the rectangle along with the area. And I will do that for each rectangle. And I will compare the areas to find the largest area of the 2. So let's do that. I've already done so in the tutorial itself, but I will start from scratch. So I will make a new project. Why not? I will first click on the new project icon, or go to File, click on New Project, and then I will use the Java class library, because why not? I'm going to click on Next, and I'm going to use let's see what I can use. How about tutorial one and then uh tutorial one copy. Why not? You can name it anything you like, and make sure you pick a good location for your project. A folder will be created in whatever you set your project's location to. I'm gonna click on finish, and I will wait for the projects to load. So once it's loaded, what I'm gonna do is I'm going to make a package to store our rectangle code. So I'm going to right click on source packages and go to the new section and click on Java package. And I'm going to type tutorial one copy dot rectangle. You can name it any package. You can name the package anything you want. But I'm gonna use a systematic way of naming things and just put the rectangle as part of the tutorial one copy package. Okay, so this will create me a new package. All right, once you're done, I'm going to go to File and click on New File, and I will choose Java class. That will be the class file for our rectangle. Click on Next. I'll name my class precisely rectangle. This is the place where you cannot use any other class name unless you know how to deal with the class names. Gonna move ahead a bit. There you go. So I'm gonna leave everything to their default values and click on finish. Good. Now that we have our rectangle class, I can now start implementing it. So first, I will need two properties, one for width and one for height. And I'm gonna make them private so that the other programs can modify them directly. They need to deal with the constraints first. So I'm gonna type private. I'm gonna use doubles for my dimensions. So I will get private double width, and I will do the same to the height. So now I have two properties, width and height. So we have double width and then double height. So the double type stores decibels, so that's why I need it. Next, I will now make a constructor for the rectangle. And to do it, first I will type the visibility of your method. I'm gonna make it public, so I will type public. And then I will type the exact same class name in our as how we wrote it here. So I'm gonna type the exact same class name because it's a constructor. So that's how constructors are formatted. Next, I'm going to give the constructor some parameters like double width and double height. And for now, I'm gonna assume that the dimensions are valid. So I'm gonna instead of using width though, I'm gonna use new width and new height. Just for now though, if you know how to deal with the parameters being the same as the property names, go right ahead and implement your method of doing things because that's your program. So I'm gonna set the width to new width now. The new width comes from the parameters supplied in the constructor. I'll do the same to the height. So I'll set the height to the new height. Alright, so that's how we initialize our object. We start with these two values. Now you can do stuff with the properties as well, but I will leave that up to you. Now I need some methods for the getting and setting of information, so I will start with the getters. To implement getters, first we need to define the get method. We have to define the visibility of our methods, just like before. I'll use public. Now I will type the name. I will type the return type. Make sure you don't forget your return type. That's a common mistake. will type that, and I'm going to use double as my return type, and then I will type something like get width. This is really common. This is a common format for naming your getters. Get property name. That's all. Then I'm going to return width. Now we can do that directly inside the method because, well, the width is just private, you know? Ah, goodness. Okay. Now, I'm going to get the height using this using a similar method of get height, and this will return the height. All right. So now, the next thing is I want to also set the width and height, but with the constraint of how should I say it? With the constraint being that it has to be 0 or larger. So I'm first going to define a method that returns a void, not a double, because we're not gonna return anything here, and we call it set height or set width for now. And I'm gonna need to supply a new width. So I will pass that on as one of the parameters. So in this case, what I will do is I will add an if statement saying if new width is bigger than or equal to 0, then I will set the width by using the assignment operator to new width, like so. Now, what about if we supply anything else? Well, we can actually output an error message, and I'm gonna say something like width error width should not be negative, something like that. Now you can do the same you can do the same to the height. I'm gonna copy and paste the method, and I'm going to say height, and I'll replace the width with heights. And I'll do the same here. So yeah, that's about it. Make sure you save your work every time before you go. And finally, now that we have the getters and setters, I need to calculate the area. So what I would do is I will return a double, and I'm gonna say get area, which is one of the behaviors of a rectangle. I'm now going to return. First I will get the width, and then I will get the height. So you can do operations to the values returned by your getters. That's really cool. You can do the same to any other method that returns a value. And that's very handy, yeah? Okay. Excuse me for a bit. My nose was a little itchy. So now, what I'm gonna do, oh, not the start page. I'm gonna make a main class now. And this main class will actually consist of the main method we can use to make our two rectangles to test it out. Let's do that. First things first, I'm gonna go to File, New File. I'm going to instead of using the Java class, I will use the Java main class, which will have the main method. And I'm gonna call it rectangle tester. You can call it anything you want because we're not gonna make any constructors whatsoever. So I'm gonna say rectangle tester. So now we have the main method here, which we will code the application's logic here. So in our case, first I want to make two rectangle variables. So I gotta type rectangle as our data type, R1, being a new rectangle. So new rectangle basically just makes a new rectangle object. So I'm gonna say something like 10 and 50. And then I'm going to also make another rectangle. That is going to be 62.8 and 31.4, which is a larger rectangle, as you know. So now, what I'm gonna do is first, I'm going to print out the properties of the first rectangle. So first, I will print out its width. Now, you may have noticed that I'm using the suggestions menu, which can be accessed using control space. So what I'm going to do is I'm going to use system.out.println. And then I'm going to type something like rectangle once, maybe it has the width. And then I'm going to concatenate using the plus operator outside of the ending double quotes. And I'm going to say R, and then I'm going to get the width of our R1. Okay. Now, to use the suggestions menu, you just use the up and down arrow keys to choose and press Enter or maybe Tab to confirm your choice. Now, since I don't want to like copy like the rest of these things, I'm going to oh whoops. Since I don't want to repeat the same thing the same like typing all over again, I'm going to just copy and paste. So I'm gonna have height and I'm gonna also have area, which will correspond to their methods like get height and get area, like so. Now, what I can do is instead of like writing the system.out and all that all over again, I can copy the 3 lines and paste it. So now I can replace the 1s with the 2s in this section so that I can deal with R2 as well. So that's all for the properties of both rectangles, but we also want to compare the areas of the rectangles. So let's use an if statement for now. I'm gonna say something like if the first rectangle's area is larger than the second one's area, then I will output the first one's area. Otherwise, we will output the second one. So to put this into code, if we use the if statement. So we say if R1 dot get area is larger than R2 dot get area, you can use variables to store the areas, and that's fine too. I'm going to output I'm gonna write the system.out like this. So I'm going to say the highest area is, and then I'm gonna say and then I'm gonna use R1's area, so I'm gonna use R1.getArea, like so. However, how about the second one? What if the second one's larger? Well, we can add the else statement, and then we add another code block that will house what happens when the condition returns false. In our case, we're just gonna output the second rectangle's area. And that's it for our main methods logic. So to run it, in this case, in the form of a class library, I'm going to click on run and click on first compile file to make sure that they're all good. And then I'm going to say run file, or shift F6 if you want to try it out. You should see that the rectangle 2's area is put as the highest area, and that is what we need. And yeah, that's it for the demo, and that is actually it for our tutorial. So yeah, if you have any questions, feel free to DM me. I'm not sure if I can get to everyone's questions, but yeah, feel free to DM me, and then I'll get back to you as soon as possible. Thank you, everybody, and have a good night. Bye.